Hello, everybody. Welcome back. Let us look at the problems now, which I'll be trying to solve. Those are on a reduction formula. I'll be using it. So, and then we'll move on to the next kind of problems also. So, let us waste no time and we'll try to solve on those problems as of now. So, uh, if you have any queries, you can ask. So let us start with the problem. Okay, solving the problem. Now, now let us look into this problem, which is of integral. Integral. You have integral, which is which is 0 to 2a. Okay, 0 to 2a. X square by square root of 2ax minus x square. Okay, dx. Let us look at this problem now. Now, for these kind of problems, got to substitute x as some substitution. I am doing as 2a sine square theta. Okay, so now if I substitute this for x, okay, because we have reduction formula with respect to sine, so that's why I'm considering that now. Now let us substitute it. Now we want dx also, so dx will be this is 4 times a sine theta, and differentiation of sine is cos theta and dt. Because you are differentiating with respect to x on the left hand side and differentiating with respect to theta on the right hand side. So I get this. So let us substitute that, and as well as the limits also changes. So the limits would be 0 to pi by 2. As you know, when you changing the variable from x to theta. Okay, that's what. Now this is in terms of theta now. So theta ranges from 0 to pi by 2. So let us substitute it. So I get this is 4a square. This is sine and power 4 theta. This is done for x square. Okay, divided by square root of 2ax is again I'll simplify it. So it is 4a square. This will be sine square theta minus again x square, which is 4a square sine power 4 theta. Okay, and don't forget what is dx here. So let us substitute what is dx here. So that is 4a sine theta and cos theta. Also theta. So I substituted all the things which is required now. So let us try to simplify it further. So if I take this outside, so I get 16 times a cube. If I try to simplify all the terms which I had. Okay. So 0 to pi by 2, 0 to pi by 2, and afterwards simplifying further. So this will be sine power 5 theta. That's for that. Okay. Now further, if I try to simplify with respect to denominator, I'll have 2a. Okay, 2a sine theta square root of 1 minus sine square theta, 1 minus sine square theta into d theta. That's what I got the denominator. Okay. Now further simplification. Now this is cos square, which is cos, and cos gets cancelled. So and one sine term gets cancelled, and here a I get, and this is a square, so a square I get, so this is 8, okay, 16 by 2, which is 8, and integral 0 to pi by 2, okay, 0 to pi by 2, okay, and this is sine power 4 theta, the whole, if I simplify, okay, so I get, if I by using reduction formula, this is 8a square, okay, and this would be 3 into 1 divided by 4 into 2. Okay, further if I simplify this, I get this result as 3 pi by 2, and this is a square. So that will be the solution. I hope you understood this problem. Let us move on to the next problem. Okay, I have just suggested one such method by substituting it. There are various methods, okay, uh, to reduce that. Okay, let us move on to the next problem. What we have as integral 0 to infinity x square by 1 plus x square and the whole square dx. Let us try to solve this. Okay. Earlier in this problem, I have taken as x as 2a sine square theta. Let us consider here as x is equal to tan theta. X is equal to tan theta. Okay. So now dx will be, now differentiation of tan theta will be secant square theta d theta. Let's substitute that whatever I said, and here it will range from 0 to pi by 2. Okay, so it will range from 0 to pi by 2. Okay, now this will be tan square theta, and this is divided by 1 plus tan square theta, and this is whole square, and this is secant square theta into d theta. Okay. Let us simplify this further. Okay. Now this is secant square theta, so power 4. So 1 power 2 gets cancelled. So I'll be left with only here is 0 to pi by 2. This will be tan square theta divided by secant square theta and d theta. So that's what I get. So again, if I simplify this, I get as 0 to pi by 2, and this is sine square theta and d theta. And again, using reduction formula here. So let us do that. So 1 by 2, and this is pi by 2, which is pi by 4. This will be the solution for this. I hope you understood this problem. Let us move on to the next problem here. Okay. Let us move on to the next problem. Now, let us show that. So, you have 0 to a x to the power of n divided by square root of square root of ax minus x cube, x square, okay, dx. Okay, a is equal to 1 into 3 into 5, okay, uh, so on 2n minus 1, okay, and 2 into 4 into 6, so on 2n, okay, into pi a to the power n. let us show that, and also let us, this is what you got to show, and let us also evaluate 0 to 5, okay, x cube by, you have square root of 5x minus x square and dx. Okay, hence evaluate this also. Okay, let us waste no time. Let us find the solution for that, and we'll try to get the above result also. So we have, let us put x is equal to a sine square theta. Let us put x is equal to a sine square theta. Okay, so when you are substituting it, that also differentiate this also. So I get this as 2a sine theta and cos theta as well as d theta. So this is done. So again, let us change the limits. So the limits will be 0 to pi by 2, 0 to pi by 2. Now this will be e to the power of n, and this is sine 2n theta divided by square root of this whole thing, and this is will be a square sine square theta minus a square sine power 4 theta. Now dx, which is 2a sine theta cos theta and d theta. Let us try to simplify this further. Okay, so if I take here a sine theta as common, okay, so here a sine theta is there, so those two gets cancelled, and here 1 minus sine square theta, which is cos square theta, and square root of that will be cos theta. So I'll be able to cancel cos and cos. Okay, so I'll be left only with here, which is 2, okay, which is constant, and here I'll be having one only a to the power of n only alone. Also I'll be having 0 to pi by 2, okay, which is the limits, and I'll have only sine to the power of n 2n theta and d theta. That's it. The rest all gets cancelled here. Okay, so let us use a reduction formula sine, which is 2an, and this is 2n minus 1, 2n minus 3, okay, this is 2n minus 5, okay, and it is 5, 3, and 1, 5, 3, and 1, divides by, completely divide by, you have 2n, okay, and 2n minus 2, and you have 2n minus 4. Well, this is 4 into 2 in the denominator, and don't forget this is pi by 2, because here it is even, 2n being an even here. Okay, so let us finally put the answer here. If I try to simplify this further, I get 1 into 3 into 5, and this is 2n minus 1 divided by, this would be 2 into 4 into 6 and 2n, okay, and which is pi e to the power of n. So this is the final result which I get. We have showed it. Now we have to deduce this to get the required result here. Now considering this, let us put for the result here what we have obtained, which is put n is equal to 3 here. Okay, n as 3 and a as 5. N as 3 and a as 5. So I'll get, that is 0 to 5 x cube, where n is 3, and the square root of this is 5x minus x square and dx. So if I substitute that here, so 1 into 3 into 5 divided by 2 into 4 into 6, which results to pi into 5 cube. So if you try to simplify cube, which is 625, okay, 125, and into 5 again you have, so that is 625 will have, and in the denominator will have 16 into pi. So this will be the solution. Okay, let us move on. Next problem. So in the previous session I have taken with respect to sine and its reduction formula. Let me try to solve for cos term. Okay, let me arrive into that reduction formula for what we have as reduction formula for integral cos to the power of n x dx. Let us arrive into this. So again, taking this as in. Okay, so in, which can be written as cos to the power of n minus 1 x into cos x dx. Okay, again we have integration by parts. Let us do that. So we get, this is cos power x, and integration of that would be sine x minus integration of this n minus 1 cos to the power of n minus 2 x. Okay, this is done. Again cos is minus sine. Okay, so we have sine x also here, so dx. So that's what we get. Now sine square can be written as 1 minus cos square, so that I will be doing it. So let us put that here, same, and this is sine x integral. We have, this is minus and minus, you will get plus, yeah, plus here, and n minus 1 if I take outside. So I'll have cos to the power of n minus 2 x, and this is 1 minus cos square x and dx. Fine. I hope you understood this. Let us try to simplify this further. Okay. So I get cos to the power of n x into sin x, and this is n minus 1. Okay, integral cos to the power of n minus 2 into x and dx, minus we have n minus 1. This would be just integral cos to the power of n x dx. So we have taken in as cos to the power of n x into dx. So let us consider this, and this would be I n minus 2. So you have cos n minus 1 into sin x plus n minus 1, that is what I said, n minus 2, and this is minus 1 and in. So what we have in the left hand side is in. So when you try to simplify this, I get in as cos n minus 1 x into sin x, okay, divided by n, okay, plus n minus 1 a n, and this is I n minus 2. So this is the reduction formula which we got. We got the reduction formula. Let us try to evaluate this, and let us find the integral of for cos to the power of nx dx with the interval which is 0 to pi by 2. Let us get that result also. So please try to remember this reduction result, reduction formula result, which will be helpful for solving the problems. Okay, let us evaluate. Let us evaluate 0 to pi by 2. Okay, 0 to pi by 2 cos to the power of n x into dx. Okay, let us obtain this result here. Okay, now consider this as am. Consider this as am. Okay, the previous result what we have got, let us write down that in as uh, cos to the power of n minus 1 into x sin x divided by n plus got n minus 1 by n and I n minus 2. We got this result. Now here I have the limits which is 0 to pi by 2. So if I take the limit which is 0 to pi by 2, this won't affect here. The limits won't affect here. So if I try to simplify this, so this part becomes 0. I will be having only in as n minus 1 divided by n in minus 2. So this is the result which I get. Okay. Now further, if I try to obtain the results, uh, which we get in as n minus 1, okay, by n, and n minus 3 by n minus 2, and n minus 5 divided by n minus 4. Okay, the whole thing is multiplied. Okay, so I'll have 2 by 3 I1. Here I'll have n minus 1 divided by n, okay, and n minus 3 divided by n minus 2, and n minus 5 divided by n minus 4. Okay, this is 1 by 2, not. This is for n which is odd. Okay, this is for n which is even. Okay, let us find the result for I1. So that is 0 to by 2 if I substitute it there. Okay, so I get cos x dx. So which results 1. Also let us obtain what is I naught. Cos for 0 which is 1. So I'll have only by 2, and this is dx. So I get this as 4. So I1 I got that result as 1, and I naught I got this result as by 2. Let us look into the problem now, as we have talked about that. Okay. Okay. Let us try to solve problems here. Okay. By using or employing reduction formula, let us integrate cos over 6x dx. Let us integrate cos power 6x dx. So which is nothing but I6. Okay. So by using the formula which we had, which is In as n minus 1 divided by n and in minus 2. Okay. So I6. Okay. Since we have to use even that cos n minus 1 x, okay, and sine x divided by that also. So here, this is for the result only for 0 to pi by 2, but I have for the indefinite integral also. So that's what I'm supposed to do it. So let us substitute it. So I get this as 1 by 6. So n being 6 and cos power 5x, and this is sine x. Okay, and this is 5 by 6 I4. Let us find what is I4. Okay, so that is 1 by 6 cos power 5x and sine x and 5 by 6, and this will be cos cube x sin x divided by 3. Okay, and this will be uh, 3 by 4 by 2. Again 1 by 6 cos power 5x sin x 5 by 6, or if I this is n, so n is 4. So if I put this as 24, okay, so this is cos cube x and sin x, and this is 15 by 24. I2 would be uh, cos x sin x divided by 2, and this will be 1 by 2 I naught. Further, if I simplify, if I simplify on whole, so I get 1 by 48. Okay, if I try to simplify it, 1 by 48, 8 times cos power 5x plus 10 times cos cube x plus, this is 15 times cos x, and this would be multiplied with sin x, plus I'll have 15x. So that will be the solution. Now let us evaluate uh, by definite integrals here. Okay, let us obtain that result here. Okay, let me try to solve this. Okay, if I have integral 0 to pi by 2, we have cos over n into x dx. Okay, let us evaluate what is I5 and I6. Let us evaluate I5 and I6. So uh, I5 will be 4 into 2 divided by 5 into 3, which is 8 by 15. I6 would be now here you had n as odd, here n as even. So that would be 5 into 3 into 1 divided by 6 into 4 into 2 into 5 by 2. So this results to 5 by 32 into pi. I hope you understood this. Let us move on to the next problem. Let us integrate here 0 to 2 pi. Okay, 0 to 2 pi cos power 4x into dx. Let us integrate this. Now we don't have for the limits which is 0 to 2 pi or 0 to pi and so on. We have for 0 to pi by 2. So let us reduce in that form here. So this can be written as integral 0 to pi. This is cos power 4x dx. Okay, plus integral 0 to pi cos power 4 2 pi minus x into dx. Okay, so this can be written as 2 times that of 0 to pi cos power 4 x into dx. Again, this I can write as 0 to pi by 2 this is cos power 4 x dx. Okay, and this is 0 to pi by 2 cos, now that would be pi minus x into dx. Fine, plus of x. This again, if I multiply it into 2, so I get 4 times that of 0 to pi by 2, and this would be cos power 4x dx. Now n being an even here, so I get 4 into, this is 3 into 1 the numerator and 4 into 2 in the denominator, and it is pi by 2. So I get this result as 3 pi by 4. Okay, we'll see some more problems in the next session. Thank you for listening. And again, please send me the comments also.